What's exciting to me about this solution is that it's one of the few times when AI is actually the best answer and it's not a gimmick. Hi, my name is Nick Banker and I'm a data scientist here at Pave. Today we're going to be talking about job matching. So historically, if you wanted to do job matching, the industry standard was you would consult a survey provider, they would give you their catalog of jobs, and you would have to map each employee from your organization to that catalog, either by someone internally doing this or by paying a consultant. This process is quite slow. It can be expensive if you use the consultant. And it's also quite error prone if you have someone internally doing this who's maybe not exhaustively familiar with the system that the survey provider uses, or even something about your own org chart that might be a bit confusing. I've always felt that this process of mapping jobs to any classification system was tailor-made for the modern machine learning method of an LLM. And we here at Pave leverage them heavily to do this process internally. So at Pave, we break up job matching into two distinct components. We have job family and job level. Family being the classification of what you do for a living. Are you an accountant or a product manager? And level being a relative measure of seniority within the family we assign you. So are you a senior manager of product managers? Are you a accounting intern? And both of these sets of tasks are performed separately when we do this process. For job family matching, we use a series of LLMs, which is very much taking the exact process that somebody doing this classification using traditional service providers would perform and exhaustively documenting it and codifying it so that we can just give it to a machine to do basically the same task. If you think about how job matching works, it's a bunch of individual classes, and most of the pieces of information you want to know that help you decide what class an employee is put into are text or descriptions. And these are things that traditional machine learning methods didn't really work very well with, but LLMs are perfect for. So we can say, here's an exhaustive list of all of the possible categories. Here are all of the things we know about this employee. Use your best judgment according to all of these additional rules of do's and do nots to decide which category this employee should be assigned to. And we perform this using several different prompts that each focus on maybe different subsets of employees, some for execs, some maybe for more junior employees, some people for hourly workers. We perform all these tasks. We generate predictions from each one. And then we have a second round that has a series of prompts that review all of the predictions. And crucially, we can update the system if we notice any particular mistake at any part of the process to say, don't do that ever again. And that means that not only are we getting something that's higher quality, every single month we can go in and make targeted improvements to parts of the system that mean that you're going to get a more reliable and accurate set of benchmarks month over month as long as we use this. You could think of this very much like in the example traditionally of a senior member of your total rewards team looking over the work done by this classification system initially, or the consultant reviewing something done internally and saying, hey, I think this one was wrong. So we have a couple error handling checks that ensure there's sort of robustness to our classification system. We take all of those predictions, we add them together, and we have them vote on which one we think is the best for every individual employee. And when there's a high degree of consensus across a lot of these different models, we then use them to inform the benchmarks we generate in Pave. What's exciting to me about this solution is that it's one of the few times when AI is actually the best answer and it's not a gimmick. It takes a process that used to be quite manual, time-intensive, error-prone, and expensive, and turns it into something that is quick, accurate, and automated.